Hello and welcome to the Steam Powered Channel. It's a beautiful summer morning here in lovely North Valley, New York, and we're steamed up and ready to go on a job that has to do with an antique gas pump, about a 1920 vintage. It's pretty high-end restoration, and the customer brought a part of a gear that was broken in two and half of it was missing, so we're going to do that. We're going to make a gear for it, and I'll show you how that progresses. It's quite a long video today, so let's get started right away. Okay, the job is to make this gear. It's broken. It goes to this antique gas pump. Half the gear is missing, a little less than half the gear, actually. So by putting it on a piece of paper and tracing it and turning it around and around, I've determined that it actually was a 44 tooth gear. So we got to spec this gear out. As far as the diametrical pitch of the tooth is concerned, we can use the gear formulas. So I'm going to use the old Henry Ford shop manual, and in the standard gear formulas that they give, one way to find the diametrical pitch is with this formula. Pitch equals the number of teeth plus 2 divided by the outside diameter. So those are things that we can determine. So the diametrical pitch equals the number of teeth plus 2 divided by the diameter. And because there's a little more than half of the gear left here, it's kind of easy to measure right across the center of the hole, because it's an even number of teeth. The diameter is 5 3/4 inches. So that'd be 5.75 equals 8. So the diametrical pitch of this gear is 8. So, in order to figure out what cutter we need, we go to this table, and this has got the numbers of each one of the diametrical pitch 8 cutters to cut these number of teeth in this range. So to cut a 44 tooth, we're in here between 35 and 54. So that would be a number 3 cutter and an 8 diametrical pitch, and I just happen to have one of them. The way this gear works in this gas pump is the gear is situated between 2 racks. So, and there's a shaft coming through the gear. It's got a long handle on it, about 4 feet long, so that when the operator pumps the handle back and forth, these racks go up and down. One goes up and the other goes down. And they're hooked to pumping cylinders in the top of the pump. They pump the gasoline up into a glass reservoir on top of the pump that's graduated in gallons. So you pump up however many gallons you want, and then it drains by gravity down through the hose into the nozzle into your gas tank. The next part of the operation is to set the dividing head up to cut 44 teeth. which I've explained how I did it on several other videos, but it's just a matter of using the formula, which really isn't a formula, it's just messing around with fractions. You take, since almost all dividing heads are 40-to-1 reduction, you just take 40 over the number of teeth that you want, which is 44, and you got a fraction. So you either reduce this fraction by multiplying both the top and the bottom by some number, or dividing both top and bottom by some number, and you play around with it until you find a plate, the bottom number to be a plate that you have that number of holes for. So if I had a 44 tooth plate, it would be perfect, because I just use 40 holes on a 44 tooth plate. Well, I did this from before. I wrote down all the numbers of the numbers of holes in the different plates. There's 4 plates in this set, and there is no 44. So I doubled it and made it 80 over 88, and there's no 88. What did I do with it? Oh, here it is. Or you could divide it in half and make it 20 over 22. Well, there's no 22. There's only so many numbers that'll divide into 44 equally that you can divide both top and bottom by. So it drove me nuts. So I reduced it down to 10 teeth out of 11 by dividing this by 4. Becomes 10 teeth in an 11 tooth hole. So I went ahead, this is a little out of numerical order for this video clip, but I made an 11 tooth hole, 11 hole circle, I should say, in the space that was left over on this one plate. Then I went back and I got to thinking, why would they not make a way to cut a 44 tooth gear? I mean, that's ridiculous. So I said, there's got to be a chart somewhere that has all the numbers of teeth or numbers of holes for a 40-to-1 dividing head. And I looked online, and man, there is just about isn't any. And finally I was on the Practical Machinist website, and somebody asked the same question, and they said, well, Grizzly makes a nice dividing head, and their own operator's manual, their operating manual for their dividing head is, you can download it. It's a PDF file. So I did, and I came up with this very nice chart that's got all the possibilities. I looked it up. A 44 tooth, 44 divisions would be a 30 over 30 holes on a 33 hole plate. Well, that 33 is not divisible by our original formula here, 44. But I finally figured it out. I had a mental block in that I was thinking that you had to divide both of these numbers by a whole number, and you really don't. So if you take the 40 and multiply it by 0.75 and the 44 multiply it by 0.75, you get 30 over 33, or 60 over 66. You can run that fraction up and down. You don't need to bother with this if you have this chart, but I didn't have the chart to begin with. So anyway, any of these would have done: a 66, a 33, a 44, or 11, which I made. And it just so happens that I had a 66, and I could have done it with 60 holes on a 66 hole plate. So anyway, that's the deal with that. I've already got the 11 hole plate drilled, so I'm going to use that. take the best dividers you have and you punch a mark on your scribe line here to start with, and then you go around the circle and you keep adjusting this until you get it to drop right back in the first punch mark. So you get 11 marks around the circle. The drill size is number 13, 185 thousandths. Stuff drills like it's cast iron, might be. Drills very easy. Here's what it looks like set up on the dividing head with the sector guide here set it to span one hole. So we're going to go 10 holes on the 11 hole circle. So if you were in this hole to start with, when the movement came, you'd go around not quite one turn, 10 holes. Out of the 11. So the dividing head is ready to go. Before I got too carried away into this project, I wanted to do something, an upgrade on this old 1895 Brown and Sharp milling machine that I've been putting off for a long time, and I decided to just go ahead and do it. The support arm here, for as long as I've had this machine, has just been a center. It goes in the center hole of the arbor. I'll show you. Like that. And you just lubricate it, sort of like a lathe center. Well, it's not very rigid. And the way most more modern milling machines are, they have what they call a running bushing here, which is the last spacer before the nut, and it's hardened and ground, and it's a very good finish on it, and it runs in a brass bushing in the overarm. So I made one. This is it. It's a piece of 1045 steel bored out with a bronze bushing pressed in and honed to size, so that it's as perfect a fit as I can get on this running bushing. And it fits in here the same as the other, with a pin to stop it from turning. There must have been one for this at one time, but it's long gone. And that fits in a little slot here, drops back in. Now I got a screw on this side that pulls it up and holds it tight. But that will run right in there like that. And it will make the arbor much more rigid, so I can take heavier cuts, and it'll give us a smoother finish, and I'm kind of anxious to see how it does work. I'm making a arbor to mount the gear and the dividing head on the 1925 South Bend Junior lathe, and I've got the 1 inch diameter that goes in the dividing head already cut. This is what it looks like. I've got two diameters here and one threaded portion. This is 687 or 11/16. 93, so a couple more on the dial will give me 4, and that ought to do it. This is a finished tool I put in here. It's got a little water radius on it. 86.5. Missed it by half a thousand, but that's close enough. I got the 60-degree threading tool in here, and it's right on center, and it's lined up straight with the surface of the work. So that's ready to go. Now I've set the lathe up to cut 5/8 11 thread. And I've showed how to do that with the gearing and the formulas in past videos. So we're just going to use the chart here. 11 takes a 32 on the stud and 44 on the screw. So I'll switch the gears over and then show you what they look like. Okay, there it is. The 32 is on there, that's the stud, and the 44 is on the screw, on the lead screw, and this big gear is just connecting the two together. It really doesn't matter what size gear you put here. It's just an intermediate gear. It doesn't do anything as far as changing the ratios are concerned. And then you got to set the tumbler up here so that it's feeding toward the headstock. Okay, got an 11 pitch thread, which is an odd pitch, so you have to go either on the numbers or the line, either on the red or the blue here. So I'm going to go on the red just because I'll remember it. Okay, so we'll shut it down and check and see if we got an 11 pitch here. Oh, my gauge is over in the other toolbox. Okay, I don't know if you can see that very well. That's right on the money for 11. So we're good to go. Wow, I lucked out on that one. I thought I might have gone too far. That's about right. I was pretty surprised at how well that 150-year-old lathe tool worked. I got a pretty good edge on it. 3/16 keyway broach, Series B. No matter what width the key is, it's 3/16 wide. Takes a 3/16 slot. You can also get a 3/16 in a C series, which is 3/8, but you can't get a bushing in there. It'll take that size slot very easily. This requires 2 passes, and you get the proper shim with the broach. I'm going to put this blank on the arbor so I can turn the OD of it concentric with the hole, the lathe. Gear blank is set up and ready to cut, and I had intended to finish this up today, but it's 88 degrees outside and the heat index is over 90, and it's just too hot to fire the boiler. So rather than hold this video up for another week, I'm going to do it in 2 parts, and we'll see you next time, and we'll cut this gear.